In this video, we'll be talking about this new USB Smart RF power sensor. I'm going to show you what's in the box, how to perform software installation on a typical PC, as well as how to get started and perform some basic measurements. So let's get started. When you open the box, what you'll find inside the box is a USB flash drive with software and some documents. USB cable, 6 feet long, and finally the sensor itself. For comparison, here is a Agilent E-Series RF power sensor, and as you can see, this small compact RF power sensor is relatively small. Its size is 4 inches length and about 1 inch height and width. This is equivalent to about 105 millimeters width, 25 millimeters across. To get started, plug in your flash drive, which came included with the sensor, into USB port of your PC. Also, plug in your sensor into a second port of your PC so that driver automatically installs. To start the software installation, simply open your Windows Explorer and then find the flash drive. In this case, it's drive F. When you click on it, you will see some folders. Let's first have a look what's inside of Docs folder. In this folder, you will find the user manual, which you can open using Adobe Reader. And in this manual, you can read everything about this sensor, how to perform the installation, how to use it, and everything else. You will also find in here datasheet for the optional device, which is the RF attenuator, 50 watts, 40 dB attenuator. This device can be connected in front of the power sensor, and then you can perform RF power measurements on devices up to 50 watts. To perform software installation, navigate to App folder, and then just simply click on this self-executable installation file. The installation process is automated. Just simply navigate through all of the windows, and within just seconds, the installation process is complete. After the installation, you will see an icon on your desktop which says Smart RF Power Sensor, but you will also find one under your Start menu. Once you click on this icon, the app opens up. And this completes the installation process. Before we do any measurements, we are first going to familiarize ourselves with the app. To get started, simply double-click on the Smart RF Power Sensor. What comes up in front of you is the window. It's a simple app. So the RF signal field shows you the RF signal being measured, the signal level. Below that, You will see the dynamic range of the sensor between its minimum signal level and maximum measurement, which can be normal, relative, and you can have a max cold. Normal measurement is just this. A relative measurement is used for measuring cable loss or attenuator level, and max cold can be used to hold the maximum value if the signal is jumping up or down. Units, you can display the signal level in different units, dBms, watts, or RMS voltage across sensor input. Frequency, you can enter the frequency, operating frequency. For example, if your radio, for example, is operating in 144 megahertz, enter 144 and then simply press apply. This number should be as close as possible within 10 megahertz or so, but it does not have to be within a single megahertz. RF offset, here you can enter RF offset value. So for example, if you have an attenuator in front of the sensor of 40 dBs, you can enter 40, click apply, and then the result is scaled up. Under settings, you will find mode. This device can operate in continuous mode or it can operate in pulse mode. We'll talk about this in one of the other videos. Here you will also find a log data function. If you click on it, you can log your measurements. For example, test. When you click save, logging begins immediately. If you click on settings one more time, you can see a check mark here indicating the device is logging data. If you click on it one more time, logging stops, and then the file is automatically opened. So this is a CSV or comma separated values, and you can open this with Notepad or you can open it with an Excel spreadsheet for graphing. Here you will also find reset, and this reset resets the sensor. Under tools, you will find two tools. One is called RF converter. This one can be used to convert from one unit to the other. For example, 0 dBm to watts. 0 dBm is equivalent to 1 milliwatt. Negative 10 dBm. When you click apply, that is equivalent to 100 microwatts. 30 dBm, equivalent to 1 watt. Or you can convert from watts to dBm. If you click on watts to dBm, 30 watts is equivalent to 44.8 dBm. 50 watts is equivalent to 47 dBm, and so on and so forth. Then it's one additional tool here where you can use. It is called ERP, or Effective Radiated Power Calculator. Here you can calculate effective radiated power knowing output power of your transmitter, cable loss, and antenna gain. So for example, if your transmit power is 10 watts, your cable and connector loss are about 3 dBs, antenna gain 6 dB, output power or effective rated power out of the antenna is 20 watts. For example, if you can reduce this to 1 dB, then your effective rated power goes up to 31.6. Under Help, you will find About, which tells you what the software version is, as well as gives you email address should you want to contact us. You will also find User Manual, which you can open, provided that you have Adobe Reader installed on your computer. And here you will find a lot of useful information how to use the sensor. Training videos, when you click on it, you will be taken to YouTube channel. And here you will find videos related to this power sensor. Lastly, device info. Here you will find the model number of this device, serial number, firmware number of the device, frequency range, power range, as well as calibration info. We are now going to test this RF power sensor against this Rode & Schwarz RF signal generator. We are now going to enter the frequency. It's 144 megahertz on both units. And then we're going to change the power level. 12.7 on one unit, 12.7 on the other, 3.7 on both, negative 5.3 on both, 11.3 on both, 17.3 on both, 23.7, 29.9, 33.6, 36.5, 39.5, and finally negative 40 dBm, which is the bottom range of this device. We are now going to change the frequency to say 600 megahertz. We have to do the same on the sensor. Hit apply. Now we're going to change the level. 29.0, 20.0, 15, 13.2, 9.0, 5.8, 2.0, 1.8, 11.6. Notice the dynamic range here. It has just turned yellow. If you back down the power level, it turns green. If you go up towards the maximum, it turns yellow, indicating that it's getting close to the maximum. If you keep going and get to the very top, it becomes red, and it tells you that the maximum input has been reached. If you back down, it turns green again. Now let's do the test at 900 megahertz. Hit apply. Power level negative 9.7, positive 9.7 on both units. If we reduce this down to 6.1 on both units, 3.1, 7.7, 16.6, 26.4, 34.0, 38.5, and so on. Finally, maximum frequency of this sensor is 1 gigahertz. We enter 1000 megahertz on the sensor. Level is negative 38.5 on both units, negative 21.9 for example, negative 11, 2 dBm, 5.6, 11.0, 11.6. Next, let's change the frequency to 27 megahertz on both units. 11.6 on both. Level negative 15 on both. 21.2, 26.3, 31.4, 33.8, 39.8. And then finally, let's test this device at 1 megahertz, which is its bottom range. 39.6, 39.8, negative 20 on both, negative 3, 5.8, 2.3, 6.2, 6.3, 9.4, 9.3. And there you go. You can see that this RF power sensor is very accurate between 1 megahertz and 1000 megahertz, between negative 40 dBm and plus 15 dBm. And it has been compared to the state-of-the-art Rode & Schwarz RF signal generator, and as you can see, the sensor tracks the output power relatively well. And then finally we come to the end of this introductory video where I've showed you how to use this device, how to perform software installation, and what this device is all about. Thank you very much for watching. Like and subscribe for more videos like this.